Dear friends, welcome to Bond with Chemistry YouTube channel. In this video, I will explain the previous year questions which are appeared in HCU PG Entrance Examination in Chemistry from the lesson General Organic Chemistry from the year 2010 to 2011. These are year-wise questions from the lesson General Organic Chemistry. The IUPAC name for the following compound is. From left side, when you give numbering 1, 2, the function group gets second position. From right side 1, 2, the double bond gets first position. According to first point of difference, so we have to give numbering from this side. The function group should get the least number 1, 2, 3, 4, 5, 6. The parent chain contains 6 carbons, so the root word is hex. At third position, there is a methyl group. At fourth position, there is a triple bond, so 4 ine. First position, there is a alkene, so 1 A. This is the correct option. Strongest brown-state acid among the following is. Generally, this is the trend. Aromatic carboxylic acids more acidic than aliphatic carboxylic acids, and phenols more acidic, and the next one is alcohols. This is the order. In this case, C is more acidic, brown-state acid strongest. Next one is D, and next one is A, and the least one is B. So this one is the correct option. The number of stereoisomers for the molecule is. So the molecule 1,3-butadiene type of molecule is given. 1,3-butadiene, it has a S cis form and also S trans form. Around single bond cis and around single bond there is a trans. S cis form, this is the S cis, and the S trans is this is the S trans. And in S cis also we have different groups here, H and D. Here also we have H and D. So here there is a possibility of E configuration or Z configuration or ZG configuration. In S cis we have 3 configurations. S trans also we have H and D, H and D. Here also we will get E or EZ or ZG same, and ZZ configurations we will get. So from S cis we have 3 configurations, stereoisomers, and from S trans we have 3. So the total number of stereoisomers which are possible are 6. An organic compound on decomposition at 500 degrees centigrade and 1 atmospheric pressure releases 2 ml of carbon monoxide, 2 ml of nitrogen, and 2 ml of water vapor. The ratio of the mole ratio of carbon monoxide and nitrogen and water vapor will be ratio of their volumes. So here CO ratio, nitrogen ratio, and water vapor ratio 2 ml. This one is 2 ml. This one also 2 ml, and this one also 2 ml. So the ratio will be 1:1:1. So we can take 1 carbon from CO and 2 hydrogens from H2O and 2 nitrogens and 2 oxygens. This is the simplest molecular formula, the empirical formula of the molecule. So D is the correct option. The intermediate acid involved in the following reaction is ammonium cyanide. When you decompose, it will be converted into urea. So this one contains NH4 plus unit and N double bond, C double bond O. Here you have N minus. This NH4 plus donates proton. So there is a formation of isocyanic acid. This one is isocyanic acid. Isocyanic acid. This isocyanic acid converts into, there is a equilibrium between isocyanic acid and cyanic acid. This one converts into N triple bond COH. This one is called as cyanic acid. In between conversion of this one into urea, This molecule converts into isocyanic and cyanic acid. So the intermediates will be cyanic acid. The hybridization that is common for at least one of the carbon atoms in hydrogen cyanide, hydrogen disulfide, ylene, and carbon monoxide is hydrogen cyanide HC triple bond, and we have two pi bonds here, and carbon disulfide. This is the carbon disulfide. Here also the carbon has two pi bonds, and ylene. Here also the central carbon has two pi bonds, and carbon monoxide C triple bond O. Here also we have two pi bonds. When carbon is attached with two pi bonds, it has sp hybridization. The order of basicity of the following substituted anilines is. Okay, this is the reference molecule. Here there is the introduction of electron withdrawing group, and also there is the introduction of electron donating electron withdrawing group. Here at the ortho positions we have two electron withdrawing groups. Due to ortho effect, there is a decrease in basicity of aniline. When you introduce electron withdrawing or electron donating groups at ortho position, there is a huge decrease in basicity of aniline. So this one should be least, fourth one should be least. Among the options, this one has the least one. And which one has highest? This one, generally this one has highest because second and third have electron withdrawing groups. So first one is more basic, and next one is second one due to having the electron donating group due to hyperconjugation of CH3. This one has more basic. It is more basic, slightly more basic than when compared with nitro. So second, third, this is the correct option. The rotation of pure or luminone is 123. Calculate the percentage of plus isomer in a sample showing rotation of plus 109 degrees. This is let's take a plus isomer as x. This one has 123, x into 123 plus the remaining will be 1 minus x. The fraction of r will be, sorry, the fraction of minus will be 1 minus x. The value will be minus 123. It will be equal to, the mixture has the rotation value 109 degrees. So here you will get 123x, 123x plus of plus minus of minus, you will get 123x minus 123 is equal to 109. So 2 into 123, x will be equal to 109 plus 123. Upon simplification, you will get x will be equal to some 0.943. This is a fraction. When you convert into percentage, the percentage will be 94.3 percentage. The structure of 1 and 2 shown below corresponds to. Here, lactic acid and alanine is given. The first priority OH gets first priority, and the COOH second priority, CH3 third priority. Hydrogen is below to the plane. When you connect 1, 2, 3, you are getting anti-clockwise. So this one has S. And next one, this one gets first priority, second priority, and third priority. Hydrogen is not below to the plane. When you connect 1, 2, 3, you are getting anti-clockwise. So the configuration will be R. So this one has R. The product obtained by the reaction of one equivalent of 1 bromo 3 chlorocyclobutane and 2 equivalents of Na is, it's a Woods reaction. 1 bromo, this is the 1 bromo 3 chlorocyclobutane, and we react with 2 equivalents of sodium. It's a intramolecular Woods reaction. There is a removal of fluorine and bromine, and there is a formation of bond between these two carbons. So you will get this molecule. So A is the correct option. The ester that undergoes acid hydrolysis most readily is. In acid hydrolysis, R0O or R gas. In acid hydrolysis, the attacking of water. This is the rate determines. More the electrophilic nature of C double bond O, more the electrophilic nature of carbon, more the attacking nature of H2O, and more the rate of hydrolysis. So we have to identify the electron withdrawing groups which are attached with S. Here this one is the electron donating group, withdrawing group, and the donating group. Inward is a strong electron withdrawing group. So this one withdraws electrons. When there is a withdrawing of electrons, here there is an increase in positive charge. So H2O can easily attack on carbon. So the rate of hydrolysis is more in this compound. Which of the following compound is aromatic? Here you have this one is 4 pi system. There is a this one has empty orbital. Due to having empty orbital, there is a delocalization of 4 pi electrons. Planar. So it's anti-aromatic. Suppose if you take this one, here there is a delocalization of 3 pi bonds, means 6 pi electrons, and also 2 lone pair of electrons. So totally 8 electrons are participated in the delocalization. It's not belong to 4 plus 2 pi system, so it's not aromatic. If you take this one has empty orbital, and here there is a delocalization of 6 pi electrons, and the planar, cyclic and planar, and there is a continuous delocalization, so B is the correct option. Which of the following compounds has the highest boiling point? When compared with the aliphatic, aromatic have highest boiling point due to strong intermolecular forces. So cyclohexane, this one is least. When you compare benzene, toluene, and mesitylene, these are the structures. Mesitylene, the molecular weight of mesitylene is high. This one has 3 CH3 groups, and the toluene, this one has only 1 CH3 group, and the benzene. As the molecular weight of the molecule increases, there is an increase in boiling point. So this is the order of boiling point. The decreasing order of C single bond C bond length in the following compounds is. Here there is a delocalization. Due to delocalization, this one gets the partial double bond character. Here also there is a delocalization. Here also there is a delocalization. But in case of triple bonds, due to having planarity, linearity, there is a more delocalization of these pi electrons. When there is a more delocalization of these pi electrons, this bond gets more double bond character. So third one has more double bond character, means this one should have least bond length. In which case this one has third one has least in this and in this. And also here you have one triple bond and one double bond. Okay, 2 triple bonds would have least, and the next one is 1 triple bond and 1 double bond. So second one, next one is second, and the next one is this one, first one, due to having 2 double bonds in conjugation, and this one is the CH3 and CH3. This one has a single bond character, so it has more bond length. So C is the correct option. An alkali contains CH and O. Quantitative analysis of this compound showed the weight percentage of carbon, hydrogen, nitrogen, okay, oxygen, remaining will be oxygen. So is given 70.8, 6.2, and 4.1. So the remaining will be 18.9. Okay, when you remove 100 minus these 70.8, 6.2, 4.1, you will get 18.9. Next, we have to divide with the atomic weight of their elements. We have to divide with 12, here 1, here we have to divide with 14, here we have to divide with 16. We will get around 5.9, 6.2, 0.29, and 1.18. When you divide with the least number, okay, when you divide with 0.29 and 0.29, in this one also 0.29, 0.29, okay, we will get around carbon is 20, hydrogen is 21, and oxygen is 4, and the nitrogen is 1. Okay, so this is the correct option. Choose the correct statement regarding the relative stabilities of the units 1 and 2. Here the unit is in delocalization with 2 C double bonds O. But here this one is in conjugation with it is in resonance with only one C double bond. So first one is more stable when compared with second one. So second is less stable than first one. The Newman projection and stereochemical structures of A and B are given below. The similarity between the two structures is that both. This one can be written as when you rotate 180 degrees, this one when you rotate 180 degrees, you will get CH3 here and Br here and hydrogen here. When you rotate this one 180, you will get CH3 here, hydrogen here and hydrogen here. Okay, this one is similar to this structure CH3 and CH3. This one is Br, H. This one is H and H. This one is asymmetric center. This one gets first priority, second priority, and third priority. When you connect 1, 2, 3 anti-clockwise, hydrogen at horizontal position, so the configuration will be R. So let's take this one. 1, 2, and 3. When you connect 1, 2, 3, clockwise, hydrogen is below to the plane, so this one also R. So both have the chirality and the configuration is R. The strongest nucleophile among the following is. Okay, here the nucleophilicity is due to lone pair of electrons which are present on the nitrogen. Okay, when you introduce electron donating groups, OMG is the electron donating group, and Mu2 it is also electron donating group. When compared with OMG, this one is more electron donating group, and this one also electron donating group. But when dimethyl amine at fourth position, 1, 2, 3, 4, fourth position, these electrons comes like this. So it increases electron density on nitrogen when compared with 1, 2, 3, third position. Due to resonance effect, due to mesomeric effect, there is an increase in electron density on nitrogen when Nmu2 is at fourth position. So this molecule has more nucleophilicity. The preferred conformation of the compound given below. Here methyl and OMe same side, both OMe and OMe opposite side, and methyl and ethyl opposite side. And methyl is above the plane. So if you take this one, methyl above, ethyl below, and this one is and 1, 2, 3, 1, 2, 3. It should be below. The third one should be below, but here above. Suppose if you take this one, methyl above and ethyl below. At third position, OMe is below, and fourth position, there is a OMe above. So this is the correct option. The formal oxidation number of carbon in formaldehyde is C double bond O. This is the formaldehyde. And here this one has a +1, +1, and this one -2. The contribution will be this one is -1, -1. When you cut this one is +2. So the total charge on the carbon -1, -1, +2, it will be 0. The formal charge on the carbon in formaldehyde is 0. Which one of the following is not aromatic? Okay, here there is a delocalization of 6 pi electron cyclic planar, so it's aromatic. Here also there is a delocalization of 6 pi electrons, these 2 electrons and these 4 pi electrons, 6 electrons cyclic planar. Here 1, 2, 3, 4, 5, 10 pi electrons are there. It's a cyclic, it's not planar. Due to hydrogens, due to these hydrogens, there is a repulsion between these hydrogens. This one is non-planar, so it's a non-aromatic. This one is aromatic. So which one is not aromatic? This one is not aromatic. The order of decreasing rate of solvers is with the aqueous ethanol, fastest to slowest for the following bromides is. Here, this bromine is a tertiary bromine, and here this one is secondary bromine. It's a vinyl bromide. We know that the vinyl bromide, this one gets a partial double bond character, so the dissociation of bond between carbon and bromine is very difficult. So this one has the least rate of solvolysis. So first one should be least, and the third one it's a tertiary. It can readily generates carbocation. So this one is fast, and the next one is sorry tertiary. This is the fast. The next one is secondary. So the order will be second, third, and first one. Thank you. Thank you very much.